Hey guys, welcome to lesson 3.3, and this is going to be another calculator lesson. So make sure you get your calculator handy for this. So we are going to, the first thing that you need to do is make sure that your calculator is in radian mode versus degrees. So you might see like this on your calculator. So you need to make sure that that is checked and not this one. So that's the main thing. Other than that, this is all going to be a review. If you have a TI calculator, go to mode, and you will see radians and degrees on it. And just make sure that it's in radian mode. So I'm switching mine over right now, and we're going to go ahead and get started. So go ahead and type all four of these in your calculator, just the same way that we would if it's in degree mode. So go ahead and do that, and we'll compare it. Okay, double check your answers with mine. The thing I want you to make sure that you understand is that these are all angle measurements. So like before we might have had like 32 degrees, but now we have like the radian equivalent of that. So these are all angle measurements. And sometimes that kind of hurts my head because it's just so weird. Okay, so let's transition on to down here. We've had this before. So remember how like it might say 0 to 90 degrees. So it's talking about that first quadrant. That's what it's telling us. So this is the same thing as this. So what it's saying is that it's in the first quadrant. And what it means by that is like, don't worry about the signs. Don't worry about all students take calc. It's always going to be positive. Okay, so instead of saying the sine of theta equals 1/2, it's going to say the sine of s. S is the same thing. It's an angle measurement, but it's in radians. So we're just talking about the same thing. So you're going to use that sine inverse button for this one. So go ahead and type that in your calculator. And you should get the angle measurement. So kind of, I'm stressing that because it's kind of weird, is, I'm going to round it up to 8. It's 0.3268. So look how close it is to that, but never lose sight of the fact that this is your angle measurement and this is the ratio of like opposite over hypotenuse. Okay, so think about which quadrant this is going to be in. So this is going to be in quadrant 3, and we know that the tangent of S is square root of 3 over 3. So you should be thinking, oh, wait, this looks like it should be on the unit circle. Well, it is. So we're not going to use calculators for this problem. So anytime you have an issue like this or a ratio like that, check your unit circle. Go back to that unit circle because it's either one of those 30, 60, or 45 degree special angles, which now we're going to say pi over 6, pi over 3, pi over 4 special angles. So go ahead and look at that and see what you come up with. Okay, I try to kind of write down my thought process. So I figured out that square root of 3 over 3 is a 30-degree reference angle because we're never just going to jump to pi over 6. Like, my brain doesn't go there. So it's a 30-degree reference angle, which is pi over 6 in radians. So it's some form of pi over 6, and it's in that third quadrant. So in my mind, I'm thinking, okay, let's see. That's going to be that 210-degree angle, which is the same thing as 7 pi over 6. So this is my actual angle for S. Okay, so go ahead and try these next two and see what you come up with. Oh my goodness, guys. I just figured out that I wrote this wrong. This is in, please forgive me, this is in quadrant 4. So that changes all of this is the same, but I'm going to erase this now. So we have in quadrant 4, it would be 330 degrees, which that bumps that up to 11 pi over 6. So this is my final answer because I read the quadrant wrong. So this is in quadrant 3, and then notice is all quadrants. So just kind of keep that in mind when you're evaluating that. Okay, so let's go ahead and talk about this. So for this problem, it was in quadrant 3. It had a 45-degree reference angle, because that's where tangent is 1. And so this was my thought process. This is my final answer. So between 0 and 2 pi, these are all quadrants. So what that means is that I'm going to have 2 places where it's positive and 2 places where it's negative. So we are actually going to have 2 answers here. So the next thing I did once I figured out the quadrants is I figured out reference angle. So it's going to be something over 6. So in quadrant 1, it's just 1 pi over 6 for my reference angle, or sorry, for my actual angle. And then in quadrant 3, that would be 7 pi over 6. Again, I'm using that unit circle, so really go back on that one. Okay, these are super easy. People freak out when they see these on a test, but they're really not bad. So this is your x value, this is your y value, this is a unit circle. So notice that one, that's a unit circle. So we know that x is representative of cosine and y is representative of sine. So I'm going to write out all 6 trig functions and I think it'll make sense. Okay, so I just went back on those unit circle concepts where x is representative cosine, so -5/13 right there. Y is representative sine right there. We know reciprocals. And then tangent is y over x, and so 12 over -5. So please don't get scared when you see problems like this. They are really super easy. Okay, so for this next problem, I want you to go ahead and read through this problem, and then we're going to talk about it. Okay, so we're going to kind of decode what this is saying. So we're applying angle of elevation to, first of all, this kind of hideous equation. But let's kind of decode this. So this is an actual problem. Our problem is going to be down here, but I wanted to kind of just wrap our minds around this. So 0 corresponds to sunrise. Okay, so the sun rises in the east, right? And then at midday right there, the sun is directly overhead, so that's pi over 2. And W is the number of radians that the Earth has rotated through since noon. And I think, let's go ahead and move on to this one. So this is, notice that's the same formula. Nothing's changed here. And so we have a latitude of 57.1, and the angle of elevation of the sun is 3 p.m. At that time, there's D and here's W. So just kind of see what you can make of that. Okay, guys, so this is how I set it up. I color-coded it so you could see it. Notice it gives us D and W and L, so I just transferred that degree to a radian measure. And from here, I just put all of this ugliness in my calculator, and I came up with this. And so that didn't tell me a whole lot. So even though it didn't ask me, I wanted to kind of wrap my mind around what that was. So I transferred it to degrees. So it was almost 15 degrees. So think about this. In Alaska at 3 p.m. in the afternoon, the angle of elevation would only be about 15 degrees. So they're almost looking at sunset in February. So that's kind of crazy. But that is it. We are done.